So a bit of a change where I was going to be talking on the role of NGOs in trying to in the carbon finance. We've actually got some people that are actually implementing work with partners of ours, and they'll be speaking now. So we arranged, the Wild Trust is involved with a number of projects looking at nature-based solutions as a financing mechanism for conservation, grasslands, and all our environments across KZN. But specifically, we're going to talk about these projects related to carbon and what are the opportunities of carbon finance and for grassland conservation and better rangeland management. So we've got we've got 4 speakers here as opposed to the 3, but we're just going to try and run through them quickly as presentations and have questions at the end, because I think some of the questions will be answered by the subsequent speaker. So we have, firstly, will be Sarah, who's joining us from Stellenbosch, where she's working towards her MPhil at the Center for Sustainability Transition, Stellenbosch University. Then Sfundo, who is currently an intern at the Wild Trust, who has just recently completed his Master's in Environmental Science and more recently has registered for a PhD at UKZN to continue his exploration of remote sensing and ecology. Rowan's passion lies in grasslands ecology, and he brings a geochemistry background, interestingly enough, from UCT to the mix. And he joined the Meet Naturally program as their technical director in 2021, and this gets him out into the field a lot all over SA, and he's really becoming one of the grassland management experts from the amount of time in the field of spending out. And last on lineup, as I said, is Dr. Amy Schroeder. Amy completed a PhD in plant ecology from the University of Beirut in Germany, but currently she is with the carbon developer task and sees her supporting the carbon development in South Africa, and particularly the grass program, the grass restoration and stewardship project, which is what largely Rowan and Amy will be introducing to us. So we'll start off with Sarah, who's going to introduce the carbon market in a broader landscape and how it can be applied. And then secondly, Sfundo is going to just give a bit more of a science-based look at measuring soil organic carbon from MSC. And then, as I said, lastly, Rowan and Amy will tie this up with a bit of introduction on how a carbon finance model can marrying the science and the implementation together. So please, Sarah, let's get started. And then as I said, we'll hold questions till the end.
Hi, everyone. I'm almost finished with my master's, supervised by Dr. Haley Clements and Dr. Matthew Child, but I'm also working for a local carbon project developer in Cape Town called AfriWorld Carbon Developments. And my master's is looking at the social-ecological impacts of carbon credit projects in African rangelands as a way to assess whether this market-based instrument is being or can be used for simultaneous goals of sustainable development and biodiversity conservation. So, as you know, rangelands are keystones for biodiversity, livelihoods, and carbon storage, and they are also systems under pressure. So, with a widening biodiversity finance gap, climate crisis, and need to support sustainable land management practices and livelihoods, this is really where carbon credits could play a role. So, carbon credits and carbon markets, I don't know if you all know, a carbon credit is a certified ton of carbon dioxide equivalent that can be traded between suppliers and buyers looking to offset their carbon emissions, either for a voluntary reason, for like reputational reasons or net zero commitments, or from a compliance reason because they have to. And it's relevant in rangelands because nature-based solutions are a form of carbon credits or nature-based carbon credits, such as avoided deforestation, improved grazing management, fire management, biochar, improved agricultural practices, which the next talk will also speak about. And so carbon credits technically have this opportunity to really hit a triple bottom line in African rangelands, but it's largely understudied, and whether this is actually happening remains to be seen. So my research, oh, okay. And then I thought this map was really nice from Dr. Nicholas Stevens, kind of just shows the significance of rangelands as social-ecological systems. The map on the far left showing the grassy biomes and where restoration is possible, but where also afforestation has been flagged as possible. And then you also have the significance for ungulates and wildlife and the ecosystem services for cattle grazing. Carbon credits, as you know or don't know, has come under a lot of scrutiny, especially nature-based credits around insufficient community engagement or transparent benefit sharing, a lot of afforestation projects being clouted as natural climate solutions, and then this idea of allowing polluters to keep polluting through offsetting their emissions. But on the other hand, there's also a lot of really successful carbon projects, especially nature-based projects, where a lot of that finance has actually come to communities and has improved land management practices. So my research, I found all the nature-based projects across Africa. That was across 6 different standards. And then using the Rangeland Atlas, I filtered out the forest projects, and then also just filtered out the projects that actually had issued credits and been verified, because to be able to sell carbon credits, you need to go through a standard that gets third-party audited, and then you can only issue credits. So I found that, I narrowed it down to 30 projects, and then I looked at the project's verification and monitoring reports to understand what these projects were actually reporting on above and beyond their climate or carbon sequestration. And then I also overlaid a land cover map to see what activities were happening in what areas of rangelands. So the yellow being croplands and the orange being protected areas, for instance. Some of the findings that I found really interesting from the projects that I looked at. So only 30 projects having issued credits is a really small amount, and it really shows how, immature the nature-based market is in African ranges at the moment. So there are much more projects under development than actually issuing credits, which shows that hopefully something like a study like this could be repeated in a few years to see what other projects are doing. And then, of course, the reforestation category is the largest, which is very concerning and has, we've alluded to afforestation rangelands in this conference already. Then I took a closer look at where the projects are and what the projects are doing. So you can see the dark blue and the light blue are transformed and mixed rangelands. So most of the projects are currently in transformed rangelands and are in the afforestation, reforestation category. And then you'll see the sustainable grazing management ones and the bush clearing biochar ones are in the more untransformed rangelands. And then I took a closer look at what these projects in the project documents, what they say they're doing and how they're classifying these areas. So for instance, like the plantations of jatropha, that they were harvesting seeds for biodiesel. They called it deforested lands or degraded grasslands. So there's a bit of a misclassification of forest versus grasslands there. The projects that were planting non-native and native tree species was the largest. And this is actually a really successful project happening in Kenya that involves like tens of thousands of smallholder farms planting millions of fruit-bearing trees. But it's also happening in grasslands and croplands, but in transformed rangelands. And then they're planting a lot of species that have economic benefit for food and medicine and fuelwood, which also then offsets the pressure from natural systems where the fuelwood harvesting would have happened. And then those ones in green in the untransformed rangelands are the more appropriate, I would say, activities like assisted natural regeneration and enrichment planting. And that's the Plan Viva projects that actually require the maintenance or enhancement of biodiversity as part of the projects. And that's happening in what they call degraded woodlands. And then there's one that's afforestation happening in grassy savannas for fuels alternatives and food-bearing species. So you're seeing this trade-off between, activities that are appropriate versus meeting the livelihood needs of the people in the area. And then that's a bush encroachment clearing, which is, I think, a really amazing way to use biochar. And then that's the final one is where your livestock and wildlife grazing and fire management could come in, but it also can come in with your sustainable agriculture methodologies. And then I went through all the project documents, the verification and monitoring reports to see what outcomes they were reporting on, and found that many, like all of the projects obviously are reporting on the goal 13 of the SDGs for climate action, but then a lot of projects were also reporting on restoring ecosystems, promoting sustainable use of ecosystems and agriculture, and most projects were, contributing to employment and income and food security. Obviously, a limitation of this is that these project documents are self-reported, and they are vested interests for the project to be validated and verified. So it would have been really nice to actually ground truth these projects and actually talk to the participants that were involved in them. So yeah, that's the bulk of my research. And in conclusion, I found that most projects were reporting on positive environmental, social, and economic outcomes beyond the climate requirements. However, a dominance of afforestation, reforestation projects does leave a lot of question marks, but then a lot of these projects are happening in transformed rangelands. So I also see that the opportunity for carbon projects in intact rangelands are largely unrealized. So we're going to have to see how that plays out in the future. And then, there were also, of course, many trade-offs between, planting non-native species, but those species, meeting a lot of livelihood needs and not necessarily being invasive. And then lastly, I think a lot of the reasons why there are so few projects that are verified and issuing credits right now are the challenges around rangelands being dynamic and variable, and soil carbon requiring long-term monitoring, as well as the heavy investment into what it takes to actually register a carbon project and get it audited. And then lastly, the methodologies are not so fit for African context with, fluid land tenure systems, things like that. Oh, and the legal frameworks. I think South Africa is one of the only countries in Africa with a compliance carbon market at the moment. So there are a lot of enabling factors that still need to come on board. Thank you.
Hi everyone, my name is Sfundo Mthiyane and I'm an intern at White Trust. I'm here to do a small presentation on some of the work that I did for my master's. So the topic for the project was modeling soil organic carbon at multiple soil depth in a woody encroached grassland using remotely sensed data. From the presentations that have been rendered here, I think we are now all aware that one of the main issue that our grasslands in South Africa are facing is that many of our grasslands are being transformed to woody dominated landscape. And this has several implications on our grasslands. Number one, it reduces the quality of a productive grazing landscape for our white herbivores and livestock. It reduces the frequency and the intensity of grazing intensity of grazing and fire, which are key factors that maintain our grassland. Also, wood encroachment has a pronounced impact on below ground nitrogen as well as soil organic carbon. And now we want to look at what are then the benefits of soil organic carbon within a grassland. So soil organic carbon provides various ecological services such as regulating climate, improving water quality, and supporting biodiversity. It improves soil structure, retain water, and provide plant nutrient characteristics, which are very crucial for increasing the resilience of the soils towards the droughts and floods. Therefore, a decline in soil organic carbon can trigger loss in soil quality and productivity. Now, from the presentations that have been presented here, we have seen that there is so much controversy when it comes to the impact of bush encroachment or of wood encroachment towards soil organic carbon. I think on Tuesday, one of the findings was having in grassland. I mean, when you compare pristine grassland and wood encroached landscape, you will find that the pristine grassland is having more of soil organic carbon. But also today, one of the presentation was saying if a grassland is transformed to what a more wood dominated, then the soil organic carbon tends to increase. So even in literature, there is so much contradictions when it comes to whether bush encroachment increases or decreases soil organic carbon within a grassland. And that was one of our knowledge gap that we really wanted to address and see really if wood encroachment increases or decreases soil organic carbon. Also, there was also controversy when it comes to the depth, whether most of soil organic carbon is concentrated at the depth, maybe around 0 to 30 centimeters, or if you go deeper, it increases or decreases. You'll find in literature, there's so many debates and contradictions. So it was very interesting to try and explore these ideas. Now, the aim and objective of the study was to estimate soil organic carbon at various soil depth, which was 30 centimeters, 60 and 100 centimeters in a wood encroached grassland by integrating Sentinel-1, Sentinel-2, PlanetScope, satellite imagery, and topographic variables. The study coupled random forest and remote sense data to model soil organic carbon distribution at different soil depth of Beasley Nature Reserve affected by proliferation of woody vegetation. The study also evaluated the spatial distribution of soil organic carbon from a woodly encroach to a pristine grassland. As I've said, the study was conducted at Beasley Valley Nature Reserve, which is just located 7.4 kilometers from the CBD of Pietermaritzburg. One of the interesting facts about this area is that, as you can see from the map, it's encroached by woody plants, but you will find that this area was once a pristine grassland, but over the past years, because of poor management, then we had the issue of bush encroachment. Although most of the area is dominated by woody plants, but we still have patches of grassland. And the interesting fact is that the management here to manage like the grassland started kicking off around 2019. And then from the images, you can really see those changes that really there is some kind of management. So we went to the field, we collected soil samples at those different depths. You can see from the pictures, it was a hard labor, but it happened. So we collected soil samples. We collected about 360 soil samples, and then we analyzed those soil samples to the lab, and then we tried to integrate the lab soil organic carbon values with what we had from our remote sense data. So for our remote sense data, we use Sentinel-2, PlanetScope images to really understand the distribution of soil organic carbon within Beasley Nature Reserve. Now, from my graphs there, first thing you can see is that from our findings was most of soil organic carbon is concentrated between 0 and 30 centimeters. And as you go a bit down, you'll find that it tends to decrease. This is in a woodly encroached grassland. And one of the things we wanted to check as well is the changes that happened. So we had a boundary that was separating those pristine grassland and wood encroached grassland. So we had a translator that was moving towards the wood encroach and toward the pristine grassland. And then we wanted to see the changes. What happens to soil organic carbon? Is it increasing or is it decreasing? And then our findings were showing that as you move maybe from that boundary, as you move towards the woody encroached grassland, soil organic carbon tends to increase. But as you move towards the, toward the pristine grassland, it tends to increase, but they vary. So I would have to explain this map further, but I'm more interested in this one. So this one was from our remotely sensed data in in combination with what we found on the field. So the map on the right, what it shows is just a classification map which shows which areas are encroached by woody plants in this area, and then which areas are pristine. So you'll see that mostly in the mix of the map is where you will find more bushes, right? So the map on the left then now shows you the distribution of soil organic carbon. So you will see that most of the areas that are dominated by woody vegetation, they have high values of soil organic carbon compared to the areas that are dominated by pristine grasses. So this shows that having more woody plants actually amplifies soil organic carbon distribution within an area or a woody encroached grassland. So in conclusion, our study established that integration of spectral information with vegetation indices provide valuable information for monitoring soil organic carbon distribution in a woody encroached grassland. We conclude that freely available and accessible SAR and PlanetScope data and topographic variables provide valuable opportunities to quantify soil organic carbon in grasslands. The study is beneficial to reserve managers and supervisors and policymakers to make informed decisions on conserving the nature reserve. The methodology that we have presented is a cost-effective and time-efficient procedure of monitoring soil organic carbon distribution across a woody encroached grassland, and the reserve manager can use these insights of the study to establish an effective land management pattern to preserve and maintain soil organic carbon pool. Thank you.
Good afternoon. Sure. Last presentation of the conference. We're very excited to get this coveted slot. We're going to be trying to relate a lot of the theory into a very practical example. We try to be very selective about what we're talking about, and I hope it's going to be useful. But I'm just going to make a plug for those who are joining the nature-based solution workshop that's happening tomorrow. I think that's going to be a really great opportunity to get into some more detail. So what we decided to talk about are the opportunities and the challenges. I don't think any of us here believe that carbon finance is a silver bullet to anything. But I thought it would be helpful to actually look at both of those opportunities and challenges. If I can do that. Okay. So the project that we're talking about is the acronym is GRASS appropriately. It's about grassland restoration and stewardship in South Africa. And there's two main instances. These are the communal sites that we are working in, and then there's also some commercial private farms that are also being implemented. And that's the two presentations. So I'm covering the communal. That's what Meet Naturally, where I'm from, is focused. And then Amy is going to tell us more about the private sector commercial side of things. This methodology that we're using, VM42, has become very popular, and I think Sarah gave some great overview of the different kind of the landscape in across Africa. We are the first registered and third-party validated implementers of this methodology. There are other carbon companies in South Africa who like to put a lot of advertising out. It's saying a different story, but in absentia, we won't talk about that. So communal lands. So Meet Naturally is working in communal lands. We only work in communal lands. The story we tell about who we are is we're a social enterprise. So we're not an NGO, but we're not also a typical for-profit company. Owned by farmers, which is a bit aspirational, driving rangeland restoration in communal areas. So this is really exciting for us. And I mean, the first opportunity that I think we can talk about is hopefully quite obvious, is just the scale of where we're working, considering, I mean, we started implementation in 2021, so it's not a long time ago. And that is the carbon finance opportunity here. Is the private sector is unfortunately where the money is. That comes with its challenges, as you can expect. The other real opportunity is all of the amazing partners that we're working with. Meet Naturally is not implementing or not directly implementing everywhere here at all. We've got a range of partners who are, you know, whether they're implementing partners or technical partners that are working across the landscape. And it's a real opportunity for us to be working with some great local organizations. Also a challenge, I'm sure. And so there's different components of our model. So we'll show them all again at the end. I mean, this is the little 5 steps of what it is that we're actually doing. But I thought it would be interesting to break down. So this collective governance question is the make or break of implementation in our context. It's this great opportunity actually where local governance has to be at the forefront in order for this to succeed in the long term, because it's not a short-term project. This is a long-term, generational, 100-year vision that we're trying to implement. And so that's this wonderful opportunity. And I came across this word with some wonderful researchers that we were talking to this week of commoning. And I love that word and what it means. And we could talk about it for a long time. Eco ranger training is what we are focused on. So we're investing in people rather than in infrastructure. So communal rangelands, there aren't fences. It changes the landscape entirely. We're working with traditional herding practices and trying to integrate the kind of ecology and the science within that, which is a wonderful opportunity. But not everybody is into this. Some people want fences. In our context, that means, great, this isn't going to be the partnership with Meet Naturally, then that's going to work. So it's not for everybody. Obviously, livestock production support is massive, that we have to be situating everything that we do within the priorities of the livestock owners and the farmers and the community members. And so this is extremely popular as a program of implementation, but it doesn't work in the absence of everything else that's also happening. Similarly, fire management support there's just such a desire. It's really incredible to see how much traction there is from people really around risk management and also fodder flow and winter grazing and the livestock that are suffering at this time of year as they're getting towards the end of winter, just because there's nothing to eat. And so there's a whole system of fire management support that's quite critical. And then, of course, this verification and monitoring. And that's where climate finance, of course, it's an outcomes-based payment. You don't get payments for trying hard. You get payments for restoration. And so we have to be demonstrating those outcomes. That can sometimes be a challenge and can sometimes scare people off. But it's also this really great opportunity if we are able to integrate that within this adaptive management system, because there is all the monitoring that's happening. So if we can make it locally relevant and contextual, then that is the opportunity to integrate it within management practice. And then, of course, there's the market access. Now, I mean, carbon finance is a market access in one sense, but here we're talking more about the livestock market as well, which is a much greater opportunity than carbon finance. I firmly believe that, having really got into the details of this, it's orders of magnitude greater. The value of communal rangelands is not in producing carbon credits. We see the carbon credits as that means to an end. And yes, finance, unfortunately, is the difficult thing in any program implementation. The livestock market access is, as we're seeing, really transformative and is what is able to sustain this long-term viability. And so there's a range of different trade-offs and tensions that I'm not going to go through now that we could be discussing. And maybe one thing to just mention is everything that I've just gone through. That's that kind of program of activities that are being implemented. You know, that has a certain cost. That has a certain cost per hectare, which we can try and optimize. But also there's the cost of compliance with the standards. That has a certain cost, which is very difficult to optimize. That's a fixed cost that is only growing. And as a result, that imposes certain limitations on what can work and what can't work. And working with these standards and working with these third-party auditors is very interesting. Maybe one anecdote to just say is we've spoken a lot about how savannas and rangelands and grasslands are understood relative to forests. There is no auditor, auditor who's allowed to audit our work that's based on the continent of Africa. We have to go to Europe, to America, to India, to Asia, to fly in these auditors. And so the standards recognize that savannas exist, which is a great win. But the individual auditors, not a single auditor or reviewer of our project has failed to raise a finding because they've spotted trees in our project area. And they're like, that's a forest, so that's ineligible. So, I mean, that's just one example of the complexity of working within a massive system with many different actors that are all working with imperfect information. I'll leave it there.
Thanks, Ruan. Good afternoon, everyone. I was here about 10 years ago doing a poster presentation as a student, and now I'm here representing a carbon project development company. But thank you, Ruan, for giving such a great introduction to the GRASS project. So I'm from TASK, and today I'll be highlighting some of the challenges that we face when we implementing the second project instance, which is focusing on the commercial farming sector. Okay, so just something small about TASK. We are a leading global carbon project developer. We've been in the carbon market since 2003, and we've contributed to one of the first cook stove credit projects in Zambia. And our mission is we finance and we develop high impact climate projects. With that being said, our achievements, we operate in 5 countries. We've created over 700 jobs, distributed over 1.2 cook stoves. And right now we have over 600,000 hectares under grassland regeneration. We've also issued over 10 million carbon credits, and we are forecasted to issue 20 million more. So yeah, we've been doing quite a bit of work. So yeah, this is basically where the GRASS project, project instance number 2, this is where we're working. And these are basically the farmers that have signed up with us. So we've started in 2023, and we had 9 people, 9 farmers that were like, yes, we're going to walk this road with you. And we understand that, you know, we are learning by doing here. And right now we have 80 participating farmers, which is quite a huge jump. And as you can see, that number of hectares, it's quite a lot. So yeah, on the commercial side, we have about, close to 300,000 hectares signed up. So of course, this is a different context to the communal. As we all know that the systems are just different and we have different challenges. So I've been working at TASK for 1 year now, and interacting with farmers, commercial farmers, I was very surprised that a lot of them actually have so much interest in wanting to change or go from a more traditional management practice to a more adaptive paddock grazing or planned grazing, regenerative grazing, whatever you want to call it. And they have lots of barriers to do this. So, there's a lot of social pressure, lack of capital for infrastructure, making more camps or getting water on the farm. And then also just really the most common one was, how do we even start? We want to make a change, but where's the support? How does this work? So the aim of this project is really to facilitate and support the farmers with making that step. So I'm going to go straight into like some of the technical challenges that we face, just because of time. So basically, as Ruan was saying, and as we know, we are needing to quantify our soil organic carbon. And this is basically how the carbon credits are created. So we look at the change between this baseline and a project kind of scenario. However, as you saw, we are looking at or working in such a large scale that we all know the grasslands are heterogeneous landscapes, soil type variability, rainfall variability, just topography, everything. So this brings me to the challenge that we are facing, because we are doing actual soil measurements, of course. And I think from a carbon side, carbon project development side, academic side, this is a challenge that we all face. Like, what is a realistic and significant sampling density? And especially when you're working on such a huge scale. So that's the one that I hope everyone can help me with. And then, as Rowan mentioned, we are registered under the VM42 methodology, and we are using a measure model approach. So we have to use, here we do our measures, and then we use a model. It's a process-based model that, kind of determines or estimates the soil organic carbon over time. And it's all dependent on land management practices. So this is also a challenge, is like, what is a suitable model to do this? Is it flexible enough to address our project assumptions, and flexible enough to add parameters and all of that? So this was a challenge of actually seeing, number one, also what is registered and what we can use according to the standard, and what is just like a good model. And then as like the whole week, as it's really stuck with me with the local soil and climate data, with this gap that, we are all facing as carbon project developers, academics. This is something that we have to do for our model. We have to calibrate it to where we're working, which makes sense. But again, there are data gaps. But to say that we really do rely on all of the publications that come out from all the scientists, because we use it to calibrate our models. And uncertainty, this is something that we all face in all of our studies. And but this is something that we don't shy away from as in our project, because Vera is also, they emphasize on the uncertainty of everything that is being done. And then historical data, this is something, we're all trying to wrap our heads around. So working with farmers, it's great. So a lot of them do keep their records, but a lot of them don't. So that's one of the things, is just looking at the model that we are using. And then moving on to the last challenge. So it's proving permanence and preventing reversibility. So of course, SOC pool is very vulnerable to any sort of land management change. So how do we actually know that the farmers are doing what they said they're going to be doing, and they're not just going to till their whole farm the next year? So ensuring this long-term storage of carbon over 30 plus years is challenging. But how are we going to address this? How do we address these challenges? So it's basically supporting farmers. So what TASK does is we provide training and implementation support in regenerative agriculture. This is the first step for them really to kind of find the network of people who are thinking the same way. You know, farmers also within their community get, you know, we stick away from the holistic management because that's not what we are promoting. It's more of how do we create the support systems for these farmers that want to actually change from a conventional way. And then we also provide support, motivation. We have hub leaders, and these are basically people that are working in the Eastern Cape. They are assigned farmers and they go and help them with, you know, what are your challenges? What's going on? What do you need help with? So there's always that constant communication. And then we do all the baseline monitoring and we cover all the sample costs. And yes, it is expensive. So doing this per farm is quite hectic. But we give all of this data back to the farmers and we use this for our stock model. Then we also monitor ecological indicators. So we do soil sampling, we do fault condition assessments, and we also do an ecological outcome verification. And again, this is given back to the farmer. And it's there for them to, of course, to plan and replan, see what's happening in their field, in their felt at that time. And then we also provide a land to market product certificate. This is optional for the farmers to join. So it's really helping them, you know, giving them another business opportunity to sell their produce. And then we provide them with a platform called AgriWeb, and this is basically a farming app where you can record your data. And yes, it is difficult sometimes to get some of the farmers to use it, but they do understand that without this data, we can't calculate our carbon credits. So it is an incentive also to keep recording. And they, of course, have this data forever. And then, of course, the carbon certificates and credit sales. This is direct cash payouts when they are the carbon credits, when they get issued. And because it's per landowner, the farmer gets these credits. So yeah, this is what TASK is doing on the commercial side. And yeah, thanks so much for listening.
Thank you. Thanks, Nini. Thanks, everyone. We're kind of running, we're not quite over time yet, but close to. I think it's great. I think it's really appropriate that we actually got the opportunity to end off this Congress with the real practical examples of stuff that's happening and how mechanisms are out there to develop to support improved grassland management. And just hopefully it's a little bit, shows a positive. There's a lot of negative stuff around carbon, but there are definitely opportunities here. I think, well, we've kind of out of time, but I think if we've got any burning questions, otherwise I have put up everyone's contact details here to go in, because I think this is quite a complex issue, which I think a lot of people probably don't know a lot about. So any one of us will be very happy to answer any questions around the carbon credit market. But yeah, we've got one question at the back there.
Hi, thanks. Just a comment for Sfundo. Thanks for the presentation. But I think it might be tricky to characterize some of the Bisley grasslands as pristine. They're certainly transformed. Some are old lands. There hasn't been sort of production for 70 years, but they are by no means pristine. And Janet and their team have done a felt assessment which shows quite poor felt quality. So maybe just to nuance that with some of the findings. Thank you.
This is a question to everybody. Given the increasing importance of soil carbon, it's been a long time since I've been in the field, so I don't know what happens routinely. Is there a need to develop a standardized protocol which includes the depth, because that's crucial, and how often down the depth profile and how far you go, and the type of analysis we do, and to have a national database where everybody is submitting their data? And if so, how do we push this forward?
Yeah, later.
Just a quick answer on the carbon standard side. I mean, absolutely, that is covered by the methodology. Is needing to, I mean, there's certain things like the carbon analysis process. You have to follow Dumas combustion rather than Walkley Black, for example. There's a minimum depth of 30 centimeters, but you can go. Well, in the methodology that we're using, there's a minimum depth. I can tell you that. And if you go deeper, you have to be reporting what depth you have been using. I think some standardization would be great. What Vera is doing is they've currently busy developing a standardized methodology that's going to be applied to all soil carbon projects, not just grazing, but all others. But that's still in development. I think it makes sense, though, as well as a community of practitioners and scientists and researchers to be exploring these kind of national databases and things. I have no idea how that would be done, so I'll keep quiet on that.
Yeah, I'd just like to add to that. I think what is important and what we try to highlight here as well is the collaboration effect. We've got a bunch of different organizations trying to do one thing. It's not really, the carbon market is a competitive space, but we've sort of partnered with a group that aren't competing and trying to, so I think there's opportunities, and I mean, maybe Fallon is the place, but I think all of us that are involved in this suite of projects would be very happy to share data and make sure it's contributing to a national database. I have had discussions with the ALC around that as well. So yeah, I think let's do that, and I think maybe you could give us some guidance too. Thanks. Yeah, I think one final, okay, we got one there and then one here, and then we've got to do a draw for some 3 hampers from our.
Is it on? Okay, I've got a question here from online. It's from Craig Morris, and he asks, Sarah, is the rangeland carbon market better developed on other continents?
Yes, I think in Australia, definitely. There's another standard called the American Carbon Registry that also has a lot of grassland projects on them. So yeah, Africa is definitely lagging behind at the moment.
Oh, hi there. I was just wondering, the people who run models, how nervous are you feeling about their predictive ability? Because the methodologies allow you to select, a number of them, and some of them will include fire and some won't. And I think fire is, something that might even benefit the carbon accumulation. So, okay, but my main question is, these models make predictions. The literature tends to say, and the literature tends to say that they overpredict. I've run different types of models and some with very different outcomes. And then you've got to monitor these amounts. And yeah, what do we do if that doesn't turn out? And I'm thinking, it's really important to get those biodiversity credits in there as well, because on our rangelands, maybe we aren't going to accumulate as much as the models are saying.
Yeah, I think I can talk. I mean, we're also looking at a number of other projects, and yes, we are concerned. That yes, we are heavily reliant on models, and I think Rowan and Amy are going. But we are also in some of our projects. We in our feasibility stage, we are comparing sort of more intact systems with degraded systems, and you can showing there's a demonstrable difference there. So we can kind of validate the models on that basis. But I think what is important is what you're saying is the other thing: biodiversity credits, water. Our colleagues presented on water yesterday. And that's what we're looking at as a suite of projects around these solutions and how we can, and it doesn't apply. What we've tested in protected areas that are largely intact, the soil, there isn't opportunities around soil organic carbon is what we've, so, but there are opportunities with other things, biodiversity. So yeah, I think one last question and then we're going to have to close it.
Yes, thank you. My question is addressed to Sfundo. I'm aiming at a similar study, and I just wanted to ask you, because maybe I missed it during your presentation, which indices from the remote sensing perspective did you utilize, and which ones did you find useful? And also, what were the technical limitations that you encountered during the study? Because I can imagine that those sensors cannot penetrate through the soil, especially at the digging depth that you used at 30 centimeters. Thank you.
Okay, thank you for the question. The last one with regards to the sensors, that's why we used different sensors because, this was the second paper that I did. For the first one, because I was only sampling at the depth of 30 centimeters, we only use SAR, because SAR is the only sensor that is able to really read what is underneath, although it cannot differentiate between 30 centimeters, 1 centimeter, but you can get data if you want to know what is happening underneath. That's why I didn't have 3 maps that differentiates 30 to 60, because it cannot do that, but really it can read the information. That's why we had to integrate different sensors. We used PlanetScope because of it a good spatial resolution. A spatial resolution, because Beasley, it's a very small nature reserve, hence we had to use a sensor with a good spatial resolution. But now with SAR, the resolution is not good, so we had to integrate those spatial characteristics and spectral characteristics. And with regards to the indices, we use the number of indices. Obviously, we had to check which one they were more significant, but part of those were your NDVI, your SAVI, but you can check the paper as well. It's already been published if you want to know some of the indices that we have used. But we had, I think, about 10 indices as well as topographic variables. Yes, thank you.
Yeah, no, I think responded in person. Yeah.